Welcome back, everyone. In this video, we're going to implement the backpropagation part of our code and our neural network, okay? So over here, this part is going to be the gradients. We're going to be computing the gradients, the partial derivatives, which we use with backprop, okay? So this is backprop, like so. And we're going to define a function called compute gradients, and remember the gradients are the partial derivatives, and I missed an E over here, so we compute gradients, and it's going to take x, w1, w2, and y. Okay, these are the values that it needs, and this will return the partial derivative of the loss with respect to w1 and the partial derivative of the loss with respect to w2 using the chain rule, okay? And essentially, we're just going to be implementing the partial derivative of the loss with respect to y hat, so this gradient, which is technically going to be equal to simply y hat minus y. Remember, we have calculated these gradients before. If it's not clear, then feel free to go back and watch those lessons. And then we're going to implement the partial derivative of the loss with respect to w2. And then we're going to implement the partial derivative of the loss with respect to w1. Okay? So now we're going to have h and y hat is going to be equal to, we call the forward underscore pass function that we defined above. And we call it with our current x, w1, and w2. Because remember, we're going to need the h and the y hat in order to compute the gradients. Now, we're going to say that dl underscore dy underscore hat is going to be equal to, and we're going to say y hat minus y. So this over here corresponds to this, okay? And since in Python we can't write this notion or this notation for the partial derivatives, we're just going to say this is d. Okay, so this is d loss and dy hat. Okay, so that's why we defined it as dl dy hat is equal to y hat minus y. So over here, this is the partial derivative of the loss with respect to y hat. This tells us how the loss changes if our y hat changes by a little. Okay. Then we also need the dl underscore dw2, and that is going to be equal to dl underscore dy underscore hat over here multiplied by h. So over here, this is the partial derivative of the loss with respect to w2. Okay, so this is essentially implementing the chain rule over here. Okay, so the partial derivative of the loss with respect to w2 is going to be equal to this gradient, the partial derivative of the loss with respect to y hat, times the partial derivative of y hat with respect to w2. And if you look at the value of this last term over here, it is simply h. Right? Because we've calculated this in the previous video, it's h times 1, so it's simply just h. Okay, so this is going to be equal to dl dy hat times h. Okay, so dl dy hat is this first term times this gradient, but this gradient we calculated over here is simply h. Okay, so remember, with the chain rule, we have to chain these partial derivatives together. The first one tells us how a small change in y hat affects the final loss. And the second one tells us how a small change in w2 affects y hat. And because of the chain rule, we can chain the gradients together. And this way we know how a small change in w2 will have an effect on the loss, even though they're not directly tied together. We need this first partial derivative to tie them together. Okay, so that's what we implemented over here. And then the next thing we have to do is the dl underscore dw1 which is going to be equal to dl underscore dy underscore hat multiplied by, and this is going to be equal to x times w2. Let's make this nicer, x times w2. So what happens over here? Well, this is the partial derivative of the loss with respect to w1. And we're just implementing this chain rule again for w1. So essentially this is going to tell us how a small change in w1 affects the final loss. And again, the same thing here connects the partial derivatives, right? Because we first have to figure out how a small change in y hat affects the final loss. And then we say, okay, well, we already implemented w2, but now we're implementing w1. So now we've basically implemented how a small change in w1 will affect not only y hat, but also the final loss. And that's why we use the chain rule over here, right? Because the chain rule tells us that if we know how y hat influences the final loss, then we can basically calculate how w1 influences y hat. And if we multiply those gradients together, or these partial derivatives together, we're going to get how w1 affects the final loss. Okay, so that's what we did over here. And so these are the gradients that we have calculated. And we're simply going to return dl underscore dw1. And we're also going to return dl underscore dw2. So these are essentially we've implemented backpropagation here with the chain rule. Okay, so that's what we've done over here. And in the next video, we're going to implement the training loop, which is going to use these gradients. Okay, and it's going to use these gradients with gradient descent to update the weights and hopefully minimize the loss function. So I will see you in the next video.